Hello, everybody.
Comparing box and dot plots.
Yeah. We're going to do some box plots, some dot plots. We're doing, with our dot plots, we've talked about these. Box plots, you did them last year. We're going to review them. So we will use box plots and dot plots to compare data by using the measures of central tendency. What is the measures of central tendency?
Mean, median, mode.
Oh my gosh, is it those?
It's median, mode, and I don't think range is part of it.
It might be.
It's called something else. I'll look it up.
The range comes into play when we do like the interquartile range and stuff like that. You have to know what it means.
So the mean, the average, add up all the numbers in the data and then divide by the number of data points. The median, your middle number. Order them from least to greatest before you find the median, or you won't find the real median.
If there's two in the middle, you find the average of the two.
Yes, exactly. The mode, the most. It is possible to have more than one mode. The range, subtract the least from the greatest.
Yes.
And any outliers is a value that lies outside all of the other data.
Get what we did there? Lies outside.
Outlier.
Outliers. In other words, it's either bigger or smaller.
And the thing about an outlier, there cannot be more than one. You can't look at it and be like, but there's just like 3 little points over here that are all by themselves. No, there's only one outlier, and it's going to be like pretty.
The whole data.
Yeah, it's gonna skew the whole data. It's going to be pretty far away from everything.
From where the mean and the median
Yeah,
is.
so that's an outlier. Again, there's only one. So let's look at what a box and whisker plot is, or a box plot. You're going to see it now. Either one, it could be written as either one. It looks like this. You've got your box and you've got your little whiskers. This one here is your minimum value, the lowest one we have. Then you've got your lower quartile. Your lower quartile is the average of all the numbers from the lowest number to the median. Then you've got the median. The upper quartile, which is your average of your upper numbers. And then you've got your maximum. You can usually tell there are more, like, the numbers are more spread out over here because it's a bigger
whisker.
It's a bigger whisker. Oh, what was the word you just said a little bit ago?
Skew? Or is it lies...
The bigger variability.
Yes.
There's a bigger variability in the numbers. So that means the numbers vary more. On this side, it's littler, so the numbers don't vary as much. Okay, so let's talk about Mark and Max. This is the homework time between Mark and Max.
Average number of hours they do homework a week.
Yes. So the lowest hour that, let's go Mark. I'll label them for you. And Max. What's the lowest hours that Mark did his homework?
It looks about 2.
It does look about 2. So the lowest would be 2 hours. What's his median amount of time that he's going to do his homework?
12. Oh, the median? About what, 7? 6.5?
Probably 6.5, because 7 would be about right there, right?
Yeah.
So I'd say the median is probably 6.5, 6.5 hours. And how about like his maximum?
12 hours.
12 hours. That is a lot of time on homework.
Yeah.
12 hours of homework. So now what do the upper and the lower quartiles represent in this problem?
The averages of the lower and the upper data.
Yeah, the averages of the lower and the upper data. So when we're looking at this, does Mark tend to spend less time or more time doing his homework? What do you guys think?
It looks to be less.
It looks to be less, right? Because this is smaller. So that means that like the numbers here are more spread out, and the ones here are a lot closer.
Right.
So
It's a more...
there's more data there.
That's the more time that he spent doing the homework at those hours.
Yes.
He spent more time at those hours than these hours.
Yes. So let's look at Max. What was his lowest number of hours?
2 hours as well.
And what was his median?
About 7.
About 7 hours, yeah. And what is his maximum hours?
12.
12. So if we were to compare these two box and whisker plots, I mean, if you look at Max, his little box here, the whiskers are pretty big, right? Mm-hmm. So does that mean that there's some pretty, like the numbers are pretty spread apart right there?
Yep.
So that means Max is spending more time in this area doing his homework,
On
right?
average, yeah.
And Mark is spending more time in this area. So who do you think does more homework?
I feel like Max does.
I do too.
I feel like Max
'Cause
does.
It's more bunched up in the top.
It's more bunched up
more
here.
Spread out.
So if I were to compare him, I would say Max spends more time on his homework. Might have a little higher grade than Mark.
Might, yeah.
I would
for
think
sure.
that's a good prediction.
Good prediction. Okay, so now let's look. We are looking at the number of siblings that the students in Miss Green and Miss Newsom's second period classes have.
Ooh, my
go
class
for
got
that.
small.
Your class got tiny. So did Miss Green's. So we're looking at the number of students that the siblings in each of their classes have. So we're going to go, this is Green, this is Newsom, and this is the number of siblings that their students have. So let's compare the mean, median, mode, and range. And we'll see if there's any outliers. So Miss Green's class, the information we have, I'm going to cover up Miss Newsom for right now.
Here we go. Write down
What
data.
what
It's
data do we have?
0, 0, 0, 1, 1, 2, 2, 2, 2.
Those 4 twos,
Yep, and then 1, 2, 3, 4, 5, 6 threes.
4, 5, 6.
And then don't forget my 2
6
sixes.
and 6. So, to find the mean, I have to add all these up. 0 plus 0 is 0, plus 0 is 0, 1, 2, 4, 6, 8, 10, 13.
I think it's 40.
13.
I was counting those for her so she could
Oh.
divide, but she's quick.
Is it 40?
I think so.
Okay, so we're
We
going
made
to
a
go.
mistake. We're in a hurry, so.
Yeah. 40. How many numbers did we have total? How many students were there total?
2, 4, 6, 8, 10, 12, 14, 16, 17.
So 17. So we just added up the little dots. So we've got 40 divided by 17, which
So
is
40 is the sum of your data, and then
Divided by the number.
Divided
the number
by-
of your
yeah.
data.
so our mean is
40 divided by 17, it is 2.3.
2.3. I like you guys to round to the tenths if you can. Personally, I don't know what
Agreed.
Then it
Okay.
should be a 4. Sorry, it doesn't matter. I guess it's
It's about,
yeah.
yeah.
it's about. So now we're gonna go median. What's the median? To find the median, I just start crossing them out, going back and forth.
Well, if you know there's 17, you can count over 8 and count the ninth number.
Yep.
Right?
It's going to be odd. It's going to work out good.
Oh, see, I don't even think about that.
There you go.
So that means there's 2 for the median. What about the mode? What one appears the most?
This one right here, whatever that is.
The 3.
3.
And the range would be
Six.
6 minus 0, which is 6. Do we actually have any outliers?
Yeah, it looks like we might.
Actually, we can only have one outlier.
That's
So do we have any outliers?
Yeah, I was gonna call this an outlier, but it's not by
It's not.
itself.
Right.
Had there only been one there,
Then it
no,
would have
it
been an outlier.
yeah. Thank you.
That
for
other
pointing
student.
that out. Yeah.
They ruined it. So now let's really quickly, because the bell just rang, go over Miss Newsom. We've got 0, 0, 0, 0,
3
0.
ones.
3 ones.
Oh, 1, 1, 1, 2, 2, 3, 5, 5, 5. So when we add up, oh, I didn't even show you those. When we add those up,
You get 25.
we get 25, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Miss Newsom, you had 14 kids.
Average is 1.8.
So the mean is 1.8.
Notice how I said average. Average and mean are the same thing.
They are the same thing. The median is, I have to do it this way. I can't count. It throws me off. We're stuck between 2 ones, which is
no. There was 14. Oh yeah, you're right. There's 14. Just
Yeah.
kidding.
okay. So
One.
it's 1 because 1 plus 1 divided by 2 is 1. The mode, the one that appeared the most, happened to be our
0.
zeros, and our range
5.
5.
is 5. So that's comparing the data, looking at it. Now they can ask you questions. Who had the bigger median? Who had the bigger mode? Things like
And you
that.
can answer those questions just by looking at the data that you
the
pull
data.
from the plot.
Yeah.
Now, how do we make a box plot? I'm gonna go over that real quick.
I'm an
How-
algorithm class. So.
Okay.
How do you
Bye,
actually
Miss
make?
Newsom.
Bye,
How do you make an actual box plot? I went ahead and made it for you because I said we're running out of time, but I just want to show you. Here's my data: 3, 4, 7, 3, 8, 9, 11, 5. Before you do anything, you got to make sure that you order from least to greatest. So I
Always
went
order
ahead-
from least to greatest.
Always, always, always. Don't assume. It looks like they're ordered from least to greatest until I throw in that
There's a
bogus
3.
3
And a 5 at
So
the end.
Make sure that you order them from least to greatest, which I went ahead and did here. Now, when it comes to making your box plot, this is the data you're going to need. You need your minimum, your maximum, your lower quartile, which is the average of your lower data, upper quartile, which is the average of your upper quartile, and then your median, which again, it's the same as any other median.
The middle number.
Middle number. Very good. So here's what we're going to do. We are going to start, well, minimum and maximum are the easiest ones to find. So
3 and 11.
Here it is. I went ahead and highlighted. Here's your minimum. Here's your maximum. And then your median is also the easiest to find. However, it looks like you want to go ahead and cross out. Well, no, I don't like crossing
That's
out.
fine.
The numbers
We don't have
go
to
away.
today, but we can.
I do this. I do my little rainbow.
Yeah.
Just so that I don't. My
Some of
numbers
my
don't
kids
go
do the
away.
rainbow as well.
I love doing the rainbow. So then I noticed how I went ahead and said, okay, well, these are my two middle numbers. If you want to add and divide by 2, that's great, but you can also just find the middle number. What's between 5 and 7? 6. So that's there's your middle number. So technically, my median is 6. So my lower quartile is going to be found between my lower data. And my lower data, you don't include that 6. You look at this data here and you look at this data here for your lower quartile and your upper quartile. So now what you're going to do there is you're just going to find the middle between those.
Yeah.
So I'm going to do my little rainbow again, but I'm going to do my rainbow upside down so that you can see that that goes with that. That goes with that. Well, what's between 3 and 4?
Well, 3.5.
3.5. You can add them together, divide by 2. It's still going to give you 3.5. Here it is. And then my upper quartile, same thing. I'm going to go ahead and
so it's between 8 and 9.
between 8 and 9,
which is
gives me
8.5.
8.5. So now I've got all my data that I need to make my box
Box
plot.
yeah.
So I went ahead and put in all the numbers that I needed. Here we go. So I plotted, before I do anything, I plot my 3, I plot my 11, and then I plot my lower quartile, my upper quartile, and my
your
median. Then I think, okay, well, I've got to make sure I've got my whisker. So I go from this line to this line, make my whisker, go from this line to this line, make my whisker, and then I create my box around my median. Okay, we'll talk a little bit more about this in class. This was already done for you just because we're in a hurry.
Yeah.
But it's nice to have so that you have the notes, and we talked about it, and we'll talk about it again tomorrow in class.
Exactly.
So thank you guys for listening.
See you later. Bye.